the mathematics class. This class is for class 9 and we are continuing with chapter 13 rectilinear figures, and we are following the textbook, that is M.L. Agrawal. In the previous class we have done up to 16 questions, question number 16. So now today we are starting with question number 17. I'll read out the question, that is a transversal cuts two parallel lines at A and B. So I have made two parallel lines L and M, means it is already given that line L is parallel to line M, and these two parallel lines are cut by a transversal. Let us say, name it as T. T is a transversal which cuts these two parallel lines L and M at two different points A and B. This much. Now what do they say? The two interior angles at A are bisected. Now interior angles at A are, we can say, this angle and this angle. These two angles are bisected. So I am making bisectors of these angles. One is something like this and other will be something like this. These are the bisectors of interior angle A. And so are the two interior angles at B. And similarly, bisectors are made of angle B, the interior angles B. Let us say something like this and something like this. Now what do they say? The four bisectors form a quadrilateral ACBD. A, this point is C, B and D. These four bisectors, 1 AD, AC, BC and BD, form a quadrilateral. First thing, we have to prove that ACBD is a rectangle. We have to prove that ACBD is a rectangle. Right now it is a quadrilateral. So we are moving on to the proof. I am not going into what is given and what is, because it is already given. According to the statement, I had made the diagram and according to the diagram I have written what is to be proved. Given, I hope you know what is given. Now, first of all, we know that ACBD is a quadrilateral. We have to prove that it is a rectangle. So we know that if in a quadrilateral we prove that all the angles are 90 degree, then it becomes a rectangle. So first of all, if we look at, let's name A, B, C, D, let us say E, F, G and H. Now it will be easy to talk about the angles. Naming, labeling or naming makes easy to talk about which angle we are talking. Now, if you look at angle EAB and BAE, these total angle, means this total angle and this total angle will be 180 degree. So we can say angle EAB plus angle FAB is equal to 180 degree. Reason is straight angle. This is a straight angle. The straight angle is there. EAB and BAF or FAB. This total is a straight angle. Now their bisectors, it means this angle. Let us say that this angle is X. So this also will be X. Let us say, or you can say angle EAB, or we can say now let me explain you. If this is X, this will be X because both these are the bisectors. If this angle is Y, this angle will also be Y because these are bisectors. So 2 times of X and 2 times of Y is equal to 180. So we can say EAB, instead of EAB, we can say 2 times of x plus FAB, that is 2 times of y, is equal to 180. It means 2 times of x plus y is equal to 180. It means that x plus y is equal to 180 upon 2, and that is 90 degree. It means if I take angle DAC, that is x plus y. So we can say angle DAC, its value is x plus y, so its numerical value will be 90 degree. We have proved one angle as 90 degree. Now this total EAB plus HBA, we will say angle EAB plus angle HBA is equal to 180 degree. Reason, co-interior angles or coplanar angles. Now if this total is 2x, then obviously HBA will be angle HBA will be 180 minus 2x, because sum of these two angles is 180. EAB is 2x. If this is 2x plus angle HBA is equal to 180, implies that angle HBA is equal to 180 minus 2x. This total angle will be 180 minus 2x. So the bisector means HBA. HBA is 180 minus 2x. But so we can say that angle DBA, this interior angle, it is half of 180 minus 2x. It means 180 minus 2x upon 2, that becomes 90 minus x. This becomes 90 minus x. At the same time, this also becomes 90 minus x. Both these angles become 90 minus x. Similarly, in triangle ACB, this angle will be 90 minus y, according to the same concept, and this will also be 90 minus y, right? So we have already written HBA. HBA is equal to 180 minus 2x. So we can say angle DBA will be 90 minus x, and then we can say similarly, I am not proving it again, angle CBA. Angle CBA will be 90 minus y. If we add these two angles, means DBC, angle DBC can be written as angle DBA plus angle CBA, and angle DBA is 90 minus x plus angle CBA is 90 minus y. So 90 plus 90 is 180. I am writing it directly. 180 minus x minus y, that can be written as 180 minus x plus y. And angle x plus y we have already proved as 90 degree. So 180 minus 90 is equal to 90 degree. So this angle DBC, it means we have proved that angle DBC is also 90 degree. This is the second part. We have proved this angle. I am writing it somewhere else because I will be rubbing it. We have proved angle DAC is equal to angle DBC is equal to 90. Now what is left? We are left with to prove that angle D and angle C is also 90 degree. So we'll be doing that. Now we will take triangle ADB. We will take in triangle ADB. We can say angle A plus angle D plus angle B is equal to 180. Why? According to the rule, what is the rule? As angle sum property means all the angles of the triangle are equal to 180 degree. So we can say angle BAD plus this one BAD, this angle, plus angle ADB plus angle DBA is equal to 180 degree. Reason is angle sum property. By this reason, by this rule we can say. Now angle BAD was X, so I am writing X. We don't know angle ADB, so let it be ADB plus angle DBA, that is 90 minus X, is equal to 180. Minus and plus cancel. Angle ADB can be written as 180 and 90 goes to that side. Minus 90 is equal to 90. Angle ADB is 90 degree. This is the third part. So we have also proved that angle ADB means this angle has been proved as 90. So I am writing here equal to angle ADB. Now we will talk about this angle. Similarly, we will take in triangle ACB. Sorry, ACB. In triangle ACB, we can say angle BAC plus angle ACB plus angle CBA is equal to 180 degree. Reason again angle sum property. Angle sum property. Now angle BAC is Y. Angle ACB we don't know, and angle CBA is 90 minus Y is equal to 180 degree. Y plus and minus cancel. Angle ACB is equal to 180 minus 90, that is 90 degree. Now we have proved that angle ACB is also 90 degree. This is equation number 4. Now with the help of all these 4 equations, equation 1, 2, 3 and 4, we can say that angle A is equal to angle C is equal to angle B is equal to angle D, and all the angles are equal to 90 degree. Hence the quadrilateral, it was written previously, ACBD is a rectangle. So I am writing only in one statement. From equations 1, 2, 3 and 4, we get, what do we get? That ACBD is a rectangle. This was the first proved, hence proved. This was the first proof. Now we will talk about the second one, that CD. We have to join line CD, something like this. CD is parallel to L is parallel to M, means we have to prove that this line joining CD is parallel to both these lines. Now let's see what we have to do in this. Now we move on to the second part. In the same diagram, they say that prove that CD, this line we have to join the line. That's why I have written construction join CD. They say that CD is parallel to the original lines. We have to prove that this CD, let me join CD, though in my diagram it is not parallel, but what we have done, joined CD. So CD has been joined. We have to prove that CD is parallel to EF and HG, or CD is parallel to L and M. So I have written CD is parallel to L and M. If you want, you can write it as CD parallel EF and parallel HG. What we'll do, we will prove that CD is parallel to any one line, maybe EF or HG, because if it is parallel to one line, so another line, it will be parallel to the another line also. Now, what is given right now? In the previous part, it was given that ACBD is a quadrilateral. But now we have proved that ACBD is a rectangle. So we can say that what is given? ACBD is a rectangle. So I have written given ACBD is a rectangle. Now, we know according to the properties of rectangle that the diagonals of the rectangle are equal, and at the same time diagonals of a rectangle, they bisect each other. Bisect each other means this AB and CD, let us say they intersect each other at point O. So let AB and CD intersect at O. Now if we consider triangle OAD, because the diagonals, we know that diagonals of rectangle are equal. Which property we are using now? Property number 1, diagonals of rectangle are equal. Number 2, diagonals of rectangle bisect each other. Bisect each other. These two properties we are using. Now if it is given, diagonals, first we know that diagonals of rectangle are equal. It means we can say that AB is equal to CD, because AB and CD are diagonals of the rectangle. Which rectangle? ACBD. If diagonals of the rectangle are equal, then their halves will be equal. By dividing by 2 in both these, we can say half of AB is equal to half of CD. Now half of AB can be considered as AO or OB, so I am taking AO, and half of CD can be considered as DO or OC, so I am taking DO. Now this will help us in what? In triangle, we can say in triangle AOD, we can say that AO is equal to DO. Why? Proved. You can say, I have just given you the explanation over here, so we can say proved above. Either no, it's not important to write, but just to make you understand, I have written proved above. Why AO is equal to DO? I have told you, because we know that AB and CD are equal. These are the diagonals of the rectangle, so AB and CD are equal. If complete things are equal, then it's very obvious that their halves are equal. So half of AB will be equal to half of CD. Now half of AB can be considered as either AO or OB, but I require AO, so I have written AO. And in this half of CD can be considered as DO or OC, but I require DO, so I have written DO. So AO is equal to DO. When AO and DO are equal, it means that triangle AOD is isosceles. Isosceles triangle. Isosceles triangle means whose two sides are equal. And I have proved that this side AO and this side DO are equal. We know that in isosceles triangles, angles opposite to equal sides are also equal. So we can say angle OAD is equal to X, that is given or that was considered to be X, is equal to angle ADO. This angle was X, we have assumed. Now since these two sides of triangle AOD are equal, so angles opposite to equal sides are also equal. If this is X, then this angle will also become X. So is equal to X. Now, if this angle is X, you can see this angle EAD was taken as X. So that can be written as ADO. ADO is equal to angle EAD. EAD. In the first part, we assume that this angle was x because angle A is being bisected by AD. So if this is x, this also has to be x. We have proved that this angle is x. We have proved that angle ADO is also x. This is x. Now this is x and this was x. Both of the angles are equal. That is why it is written ADO. ADO is equal to EAD. Now these angles can be considered as alternate interior angles. Alternate interior angles. Since these two angles are equal, ADO and EAD are equal, so they can be considered as alternate interior angles. And we know that when alternate interior angles are equal, then the given lines are parallel. So we can say that EA is parallel to DO, or EA has been extended to EF and is parallel to DO. DO has been extended to DC. So EF and DC are parallel. It means EF is parallel to DC. That has been proved that DC and EF are parallel. If DC and EF are parallel, it means DC is parallel to EF, and this is already parallel to HG. That is proved. We have to prove that these the CD is parallel to EF and HG. So these two are alternate interior angles, hence they are equal. So now I hope you have understood. You have to go at least 2-3 times because so many properties are applicable in this particular question. Now we move on to the next, that is 18th question. Now I am not moving on to the 18th question because it is again having 2 parts and this will again become a lengthy of 25-30 minutes. So 1 minute video is not feasible. So I am stopping here. In the next video I will continue with question number 18 and so on. Thank you. Stay blessed.